Safe tool descriptions determine if Claude acts like a careful operator or a confused intern. They are not just decorative, they serve as the model's operating manual. The description tells the model when to call a capability. It specifies what data to send with each call. It clarifies what assumptions to avoid. It defines where execution authority ends. Modern AI apps struggle at the language execution boundary. Users express requests in natural, flexible language. Tools require precise intent and exact input formats. They demand valid fields, stable data types, and safe permissions. A vague description can lead Claude to pick the wrong capability. It might invent missing context or call a tool at an unsafe risk level. The outcome isn't just a wrong answer, it's a broken workflow with real operational consequences. Ambiguity creeps in through names, parameters, and hidden rules. A tool named Odd Undisser seems harmless at first glance, but it can change billing status, permissions, or personal data. The parameter called user is unclear. It could mean name, email, account ID, or session owner. Safe descriptions eliminate ambiguity before execution starts. This prevents the model from improvising policy under pressure. It also stops the model from silently expanding scope. The breakthrough is treating every tool as a contract. A contract defines purpose, scope, inputs, and outputs. It also includes constraints and refusal conditions. Claude should understand the tool's job first. Before seeing the user's request, it must know its role. If the model infers purpose from code-like names, the architecture leaks risk into the most sensitive layer. A safe tool description answers four key questions. What does this tool actually do? When should Claude use it? What parameters are required? When must Claude avoid using it? This creates a clear decision boundary. The model stops seeing a toolbox of options. It now sees a map of allowed actions. It also sees rejected actions, and it knows the escalation path for uncertain cases. The input schema acts as a guardrail. Descriptions alone cannot enforce structure. Required fields, enums, and string formats matter. Number ranges and nested objects add precision. This makes requests machine checkable. The description guides Claude toward the right shape. The schema rejects anything outside that shape. Production reliability comes from combining clarity. Natural language works with strict data validation. Validation happens before any back-end side effect. Safety is ensured in real systems. Good parameters carry business, meaning customer ID is safer than customer, invoice to Stasi is safer than status, reason for refund is safer than notes. Every parameter should clarify what value belongs there. It should show where the value comes from. It should explain how the value will be used. If a human would ask a follow-up question, the parameter is likely underspecified. This means hidden assumptions are needed. Such parameters aren't ready for production automation. Tool descriptions must define danger clearly. Read-only tools can be broad in scope. Failure is usually recoverable with these tools. Right tools need narrow, precise permissions. They require confirmation gates to prevent errors. Idempotency keys help avoid duplicate actions. Explicit approval language is essential. Claude must understand that Create Invover is a business event. Refund payment impacts customer trust and compliance. Delete record affects data integrity and audit trails. Send email triggers communication with real-world consequences. These are not just functions. They carry significant operational risk. Friction in live systems is necessary. As tool libraries grow, description quality becomes a scaling problem. Anthropic has noted multiple MCP servers load dozens of tools. They consume tens of thousands of tokens before conversation starts. Dense tool surfaces lead to selection errors. This happens especially when tool names look similar. The fix isn't more tools, It's discoverable, differentiated tools, each with well scoped capabilities and sharp intent labels for every function. Safe design continues after the call. Tool results must return structured outcomes, not raw confusion or unstructured data. A success response includes identifiers. It also includes status and timestamps. Next valid actions should be clearly listed. An error response explains what failed. It identifies which field caused the issue. It states whether retry is allowed. It suggests what Claude may try next. Clear outputs prevent guessing. They help the model recover under stress. Prompt injection targets the tool layer. Tool descriptions become a security barrier. Emails, documents, web pages, and tickets may hide hostile instructions. They appear as normal content but carry malicious intent. Claude must know which inputs are untrusted. It should also recognize which tools need verification. The system prompt sets authority. Tool descriptions turn that authority into action. This happens right before any tool executes. It applies across every boundary in real time. The mature Claude architect avoids maximum power. They focus on minimum ambiguity instead. Safe descriptions lead to predictable actions. Permissions become clearly visible. Failures turn into recoverable events. The future of production AI won't favor more capabilities. It will favor the clearest, most precise descriptions. Least room for misuse means real world reliability.